In this lesson, we are going to learn how to interpret chemical formulas. Now, what is a chemical formula? A chemical formula is a shorthand method of describing the composition. The word composition is basically what is the chemical formula made of? Well, in this case, the composition of a molecules. Now, it uses symbols of elements, which is coming from the periodic table, subscript, coefficient, and sometimes parentheses. Let's review. A subscript, if we look at this chemical formula right here, we have the subscript 2 and 3, 2 and 3, indicate how many atoms or polyatomic ions in the parentheses. And we're going to look at example of each in our example below. Then we have parentheses which are needed when two or more of the same, that's a key word right here, the same polyatomic ions in the molecules. Lastly, we have the coefficient, indicate how many of the whole entire molecules. Here we don't have a coefficient here, right? But we know it must be a number 1. Over here we have a coefficient of 3. So that tells you there are 3 of Na2CO3. The whole entire thing, okay? 3 of. So it's 3 times. Now let's look at this problem and figure out what is this chemical formula talking about. Well, the task is to interpret chemical formula and count how many atoms of each element are in the molecules. So let's look at our example. Here we have Na. Well, look at Na. That subscript right there tell you that there are 2 Na. What about carbon? Well, carbon doesn't have anything there, so we know it must be 1. For oxygen, see that right there? That oxygen described by the number 3, which give you 3 oxygen. Isn't that easy? Now let's look at how this number are being changed when we have 3 of it. This is the coefficient right here. Well, we know that for Na, each one we have 2, right? So 2 times 3 equal to what? 2 times 3 give you 6. And then for carbon, we have 1 right there because there's nothing there. There's no subscript, so we know it's 1 times 3. So again, this 3 is coming from here. Give us 3 carbon. For oxygen, we have 3 right there. 3 times 3 give us what? Well, 3 times 3 give us 9. And that's how the coefficient tell you the multiple of how many of that molecules. Now let's look at this case where we have parentheses right here. See this right here? That 2 right after parentheses indicate there are 2 of this whole thing right here. 2 times. So what we're going to do is this. Let's look at calcium. For calcium, we have nothing here. So it's outside the parentheses, so we know just 1. And then for nitrogen, it gets a little bit tricky. Because in here there's 1 nitrogen, but that 2 right there tell you there are 2 of it. So we have 2 times 1 equal to 2. Well, there are 3 oxygen in this polyatomic ions, but there are 2 of the polyatomic ions. So we have 3 times 2, or in this case, 2 times 3 equal to 6. And that's how the parenthesis has an impact on the number of the atoms. And let's look at this with a combination of the coefficient. Look at calcium. So again, this tells you there are 3 times of the whole entire thing. 3 times, because that 3 right there. So for calcium, if that's 3 times, we have 1 right here. 1 times 3 give you 3. And then for nitrogen, notice how we have 1 nitrogen here and there's 2 of it. So we have 1 times 2, but there are 3 of them, so we have to multiply by 3. Give us a total of 6. You see how that works? See right here? 2 for each one of them, and if we multiply by 3, that gives us 6, which is what we have here. And over here, you already can see the answer for oxygen already. See right there? 6 in one of them. What is 6 times 3? Come from there. Well, in this case, let's look at this. 2 times 3 is what? 2 times 3, and then times 3 again. Well, this is where the 6 coming from. 6 times 3 give you 18. And this, the same thing, give you 18. And that's how coefficient in parentheses plays in terms of how our chemical formula are presented. Let's try another one. Look at this one right here. We have H without hydrogen. They're in two different places. So what's the common sense? We just add them together. We group them together. Another way of writing this is we CH4O. Well, this allows the whole entire thing to look a little bit tricky. So for carbon, we just have 1. For hydrogen, we have 3 here and 1 there. So what's 3 plus 1? 4. And for oxygen, it just be 1. Now let's look at this, how the coefficient will change everything. Again, that tells you there are 4 times of the whole entire thing. So if that's the case, what is 1 times 4? Equal to 4. And for hydrogen, what is 4 times 4? Equal to 16. And then for oxygen, what is 1 times 4? Equal to 4. And we can prove that right here. Hydrogen is 3 plus 1, give you 4 right there, or 4 right there. And it's 4 of them, 16. For carbon, just 1 times 4. And that's how you interpret chemical formula.